Hello everyone. Today we'll be discussing the topic areas of a triangle, how to find the area of a triangle, and in that we'll be introducing Heron's formula. So before we move to Heron's formula, let us start with how to find the area of different type of triangles and how all these areas can be clubbed into a single formula. Starting with a right triangle. We know a right triangle is characterized by three sides, hypotenuse and its two legs, one of which is the base and other is the height of the triangle. So, in order to find the area of a right triangle, what we had been using so far, we had been using the formula half into base into height. Suppose we have a right triangle ABC where the longest side, that is hypotenuse, which is opposite to the right angle, is given to be 13 centimeter, and the two legs or the two other sides which are forming a perpendicular to each other are 5 centimeter and 12 centimeter respectively. So, we may consider any one of these sides to be the base. So, in order to find the area of a right triangle, what we used to do, we used to use the formula half into base into height. So, here according to this given example, if we have to find the area of a right triangle ABC, then according to the formula it will be half into 5 into 12, which will give me 30 centimeter square as the area of a triangle. But what if the triangle is an equilateral triangle or a scalene triangle or an isosceles triangle? This formula is restricted only to right triangles or any triangle with a given perpendicular height. Let us see how to find the area of an equilateral triangle using the same formula. Suppose we have an equilateral triangle PQR where PM is the height of the triangle. Now, if PM is the height of the triangle, it divides the triangle into two right triangles, because the perpendicular of an equilateral triangle bisects the triangle into bisects the base into two equal halves, and we have two congruent triangles and rather two congruent right triangles. So, using the Pythagoras theorem, we can find out the length of PM. We can find out the length of PM. So, PM is equal to 5 root 3 centimeter. PQ is 10 centimeter. QM is 5 centimeter. Using Pythagoras theorem, we can find out the height PM, which comes to be 5 root 3 centimeter. Now, since we have calculated the height of the triangle using the formula half into base into height, we can calculate the area of this triangle as well, where the height PM we have just calculated 5 root 3 centimeter and the base QR will be double of QM equal to 10 centimeter. So, the area of triangle PQR is equal to half into 10 centimeter into 5 root 3 centimeter, which will give you 25 root 3 centimeter square. Now, let us take an isosceles triangle. In an isosceles triangle is characterized by two equal sides and the angle opposite to equal sides are also equal. Suppose we have an isosceles triangle where the two sides are given to be 5 centimeter each and the third side is 8 centimeter, and the perpendicular from the center, from the vertex, a perpendicular drawn from the vertex, which can be taken as the height of the triangle, divides the base into two equal parts, whereby YP is equal to PZ equal to 4 centimeter. So, again using Pythagoras theorem, we can calculate XP and or PX and hence calculate the area of the triangle. So, using Pythagoras theorem, we will have XP square equal to XY square minus YP square, which will ultimately give me XP as 3 centimeter. Now, using half into base into height, again base of the triangle is double of XP, that is equal to 8 centimeter, and the height we have just calculated 3 centimeter, and hence the area of the triangle becomes 12 centimeter square. So, every time what do we see, whether it is an equilateral triangle or an isosceles triangle or a right triangle, we are using the formula half into base into height. And it's very convenient to calculate the height of an isosceles triangle or an equilateral triangle using Pythagoras theorem, because of the property that the vertex or perpendicular drawn from the vertex bisects the base into two equal parts. But what if the triangle is a scalene triangle? There the problem arises. There in a scalene triangle, if I draw a perpendicular from the vertex, it will not divide the base into two equal parts, right? So in that case, we have to use another formula which was introduced by a Greek mathematician, Heron. So using Heron's formula, Heron's devised a formula which resulted to be so useful, and it was so constructive and useful that it helped us to derive or to calculate the area of any triangle irrespective of its side. So area of a triangle by Heron's formula, how it is calculated? It is calculated using the perimeter of a triangle. The concept of the perimeter of the triangle is used to find the area of a triangle using Heron's formula. What does the formula state? The formula given by Heron is area of a triangle is under root of S into S minus A into S minus B into S minus C. Now what are this S, A, B and C? A, B, C are the different sides of different magnitude of a scalene triangle. And the same formula can be applied for an equilateral triangle and an isosceles triangle as well. We'll come to that later. So what is this S? This S stands for semi-perimeter or half of the perimeter. We know the perimeter of a triangle is given by sum of its sides. So semi-perimeter or half the perimeter will be half that sum. So since A, B, C are the sides of a triangle, semi-perimeter would be sum of A plus B plus C divided by 2. Finding area of a triangle by Heron's formula has a lot of real life applications, day-to-day life applications, where we have to find the area of a field or area of a plot of land or area of any construction which is in a triangular form. So Heron's formula is very useful there. Had the formula not existed, then it would have been really difficult or quite impossible to find the area of a scalene triangle. Let us now see that how to apply Heron's formula in finding the area of a triangle. Before us we have example 1 in which a scalene triangle with 3 unequal sides is given. Now to find the area, let me denote the side opposite to capital A by small a, the side opposite to capital B by small b and the side opposite to capital C by small c. So here we have A is equal to 40 meter, B equal to 24 meter and C equal to 32 meter. Hence my semi-perimeter S will be equal to A plus B plus C upon 2. So S will be equal to 40 plus 24 plus 32 upon 2 equal to 96 upon 2 meter equal to 48 meter. Using this S, we will apply the formula. Area of the triangle is given by area of triangle ABC will be given by under root of S, where S is the semi-perimeter, into S minus A into S minus B into S minus C. Now substituting the values, I will get 48 into 48 minus 40 into 48 minus 24 into 48 minus 32, and the whole area will be in meter square. Calculating it further, 48 into 8 into 24 into 16. From this, I will first pick up the square number 16, and I know under root of 16 is 4. So, the under root value will be written outside the bracket. 48 can be split up as a multiple of 24. So, 48 can be written as 24 into 2, and 8 can be written as 2 cube. So, if I have 24 into 24, which is 24 square, under root of 24 square will be 24. And 2 into 2 raised to the power 3 is 2 raised to the power 4, and under root of 2 raised to the power 4 is 2 raised to the power 2. So, if the power is even, then when we divide the power by 2, we get the square root of the number. So, this becomes 16 into 24. Now, without a calculator and without actually long multiplication, how will you multiply 16 into 24? So, multiplying 24 by 10 will give me 240. Just break up. Multiply 24 with 10 plus 6. 24 multiplied with 10 plus 6. This gives you an easier way to calculate. So, this becomes 240 plus 144 equal to 384 meter square. So easily we can find the area of a scalene triangle using Heron's formula, and we can simplify the calculation like this by splitting the number into factors and also calculating long numbers the way I have taught you. Example which will enable us to understand the formula better, and also it will boost up our confidence. We have a real life application. Here we can see a track, a road in a triangular way, and the portion here is a park. What we have to do in this question? There is a slide in a park. This is the slide. One of its side wall has been painted in some color with a message, "Keep the park green and clean." If the sides of the wall are 15 meter, 11 meter and 6 meter as shown in the diagram, find the area painted in color. So, this is basically the area which we have to calculate. This is the area which we have to calculate, and these are the side walls. Again, the first task is to find the value of S. What is the value of S? S is equal to 11 plus 15 plus 6 upon 2 meters equal to, quickly, yes, 21, 22, 32 upon 2 equal to 16 meters. I insert this value of S in our formula and will quickly get the result. Let's see. So, we start with, as I have shown you, S is equal to 16 meter. Area of triangle is equal to, or area, you may write area of the painted region is equal to under root of S into S minus A into S minus B into S minus C. Let us name the sides. Let this side be A, this be B and this be C. Substituting the value of S, which is 16 meter, S minus A, that means S minus A 11 will give you 16 minus 11 equal to 5 meter. 16 minus 6 will give you 10 meters and 16 minus 15 will give you 1, and the unit we know will be meter square. Again, let us see which are the square numbers. The square numbers are 16 only. So, the square root of 16, that is 4 will be outside the square root, and rest what I told you, we have to split a composite number into its factors. So, 10 can be split up as 2 into 5. So, we see how easy it is. Again, 5 into 5, which is under the square root. The square root of 5 into 5, that is 5 square, will be 5, which will be written outside the square root, and will have root 2 only left inside. So, sometimes we may get the area in the form of an product of an irrational number. Also, every time we may not get it, the answer as a rational number. Sometimes we may get it as an irrational number. So, this area becomes 20 root 2 meter square. You may leave your answer at this point in the form of root 2 also, and if you know the value, you can multiply it with 20 to also write the answer. So, we have seen how interesting it is to find, and so scoring also. Children, I am telling you, this is the most scoring chapter of your syllabus. Very convenient, very simple calculation.
To watch the complete video, download the Upbind educational app from Play Store and App Store.